How are you doing? My name is Lars Christensen, and welcome to Ask Lars. This is episode 4, I believe. And I gotta start out by saying I'm lying right up front. This is not Sunday edition. This is actually Monday. Um, it is a holiday in the United States, and yesterday I got caught up in chores around the house. I never got a chance to do this, but it's Monday, whatever, we call it the Sunday edition. This is just an attempt for me to go through some of these emails that I'm getting on Lars.Christensen and Autodesk.com about Fusion 360. I'm so busy in my new role at Autodesk that I don't have time to do it through the week, so I'm just trying to cram some of them in here for the next, I don't know, hour or so, and hopefully it's useful for you. If you're new to the channel, or you haven't subscribed yet, I would absolutely appreciate if you would hit that subscribe button, and you also hit that little bell. Then you'll be notified when I'm live, like I am right now, when new videos comes out. So I would absolutely appreciate that. So again, just going through some emails here, trying to answer some questions, and hopefully it is useful. This is just adding a little bit more value to your Fusion 360 experience. So if you haven't subscribed, would appreciate if you hit that subscribe button. Thumbs up if you like this. Thumbs down if you don't. That's okay. And as usually, I love the comment. We should be live on both Facebook and on YouTube. And then I'll do like I normally do. I'll chop up some of them and serve them through the week. Hope you're doing good. Hope everything is good. We got the sound, got people on, we got thumbs up. It's all good. So let's jump into to the first email here. This email is from I don't know if I'm butchering your name. Sorry. I am a product design student, and I am quite new to 3D modeling. You know, we've all been there. I need help making a soft close hinge for a college project, and we need a very detailed model. It would be really great if you could help with this. Well, we have. I don't know. I don't want to encourage you. I'm not going to encourage you to cheat, right? But if we swap over here, should be able to see my screen. And I just called up exactly what it is that we are looking at here. We're looking to do something like one of these. I don't know what you call these. A hidden hinge. I definitely have a couple in my house. And they're kind of cool and they're pretty neat. So what I would recommend doing is I would actually not model this up from scratch. If you can, go ahead. But I would absolutely go to the insert and go to the insert McMaster. Because if you go in here and you search hinge, now again, I don't want to encourage anybody to cheat on that test, but there is actually cabinet net hinges in here. What is what you pretty much are looking for. And there's all different kinds of ones in here. You can kind of filter down the different ones, but here is this kind of same type of style, I think, that was shown. And if you go in and you look at those, whenever you see that is this CAD for digital drawings, you can go in and you can actually find one of these hinges. So if you click on whatever size you want, so if you're looking over here, you will see there's all the different sizes. You click on the part number, and you click on the product detail right here. Then you can go in, and if you scroll down, you will see here that you can download them as a step file. And if you click that, hit save, then it will actually appear on your screen inside of Fusion 360. And they are, you can see, I mean, they are very detailed in here. Now, they are coming in as a component with a lot of bodies in it. If I just call up our YouTube here, click on YouTube, and if we do a Lars Christensen, click on the channel, you will see that if you go to videos, and we just gotta go back like a few videos ago. Let's see. Measure 2 Alive. That's a lot of videos, isn't that? making a toggle clamp move in Fusion. If you go and you search on that video, this one here, Fusion 360, make a toggle clamp move, that will show you exactly what I would do to make this one move here. So that is that's my answer to the first one here. Behave, I'm sorry if I'm pronouncing your name wrong. That's what I would do if I was working on a project. And if, again, I'm not encouraging you to cheat, but I will tell my teacher that, hey, that's how they will do it in the real world. They will go out and borrow the model there and then make it move with all the different joints. Hope that was useful. Let's move on here. Again, this is just me trying to clean out some of my emails. The next one here is from Axel. This is actually reoccurring from last week. I didn't answer it all the way through, so I'm going to do that. Thank you, Alex, for reaching out and letting me know about that. Again, if you like these videos, thumbs up. If you don't, thumbs down. And again, if you haven't subscribed and you're watching these videos and you kind of like them, it would mean the world to me if you would do that. So if we go back into the list here of the latest videos, we did a video last week that was how to create a custom cam tool within Fusion 360, and this was Alex who sent me an email and says, hey, how do we create a custom tool? And we ended up creating a custom tool that in the end we could kind of simulate that custom tool kind of running down the part here. But I didn't answer Alex's question all the way. So I should have read a little bit further down. Sorry if I'm not reading these emails all the way into the detail. But pretty much what Alex was trying to do was to, if I understand your email correctly, Alex, excuse me, is to actually take this T-slot cutter and cut down in a piece of wood, so kind of like sinking it down, and then kind of cut a blind T-slot hole and then get out of it again. So kind of like just plunging down and go out. I'm assuming you're doing this in wood because I couldn't imagine that you could actually do this in steel. I could be wrong. You know, I'm definitely not the best, world's best CNC machine guy out there. But let me just draw up what it is that I think that Alex wants, because I think a lot of people would love this. I can show you a couple of cool tricks. So I'm going to start a sketch, and I'm going to draw it, and I'm going to use a center rectangle, Alex. I'm going to make sure that my audience is in center to show this, just to make my life a little bit easier. I'm going to do a center rectangle, and let's make it like 300 by 100 wide, maybe. That should be okay. Press Q for press pull, and let's extrude this up. Doesn't really matter. 50 millimeters up. Doesn't really matter. Now, here's the thing. And this can actually be kind of helpful when you're trying to model. If you're a machinist or whatever, like CNC programmer or something like that, many times modeling things up the same way that you would machine it can be helpful. So if I go in here and I think, all right, I'm going to plunge down with this T-slot cutter. So I'm going to create a sketch on the top face here. C for circle, and that's going to be a 50 millimeter diameter. That was what that cutter was that we created in last week's video. Again, if you go and look for the custom tool, you'll find it. I'm going to hit Q for press pull, and I'm going to go down like minus 20 millimeters. Okay, so we kind of like just have a hole here. If you have used Fusion more than a few weeks, you should feel pretty good about this. Now here's the cool thing. I wanted to show you a neat thing here. So this is the tool just kind of like going down in Z, just plunging right down. Now we're actually going to have it moving in, I guess that would be the Y direction here. If we spin it around a little bit, we got the Y axis, so kind of like go moving down here. So what I'm going to do is I'm going to open a sketch. And by the way, you see how I can't select the planes because they're kind of like, the block is in the way here. Now many times, and I do this too, you might just go up here and click one of the faces up here and find it. But you can actually, if you hover where the plane is, now you can see that the side of the block is selected. But if you hold down your left mouse button for just 2 seconds, then this little dialog box comes up, and now you'll see that I can find it right there. Click on that, and it's ready to start a new sketch. Now here's a tool that I don't use often enough. Over when you start a sketch, now remember, just to move apart here, we're actually sketching right there inside of the center of that hole, right? If you didn't know this, there is over here in your sketch palette, when you are in a sketch, a slice command. See what that just did? It's kind of like just slices. It doesn't do any, it's all visual. This doesn't do it physical, but it just makes it a little bit easier to see what you're doing when you tick that little box there. All right, so what I'm going to do is I'm going to go normal 2 again, and I'm going to select P for project, and I'm just going to select that in half of this hole here. Hit OK. That will give me the endpoints here. So now I'm going to do the bottom side of the cutter, and that's going to be 10 millimeters tall. That's how big that cutter is. And if I just hit OK, then the box can kind of move back and forth. We could do something like a vertical constraint from this point to this point. Boom. So then we have that there. And then we're going to do the shaft. Now, Alex, when you're doing this, I'm assuming that you have some kind of a cutting edge on the shaft, or you're going to have problems, but maybe you do. So let me just go over here and draw a rectangle out here in space. This is another thing I many times do, and it doesn't really matter how tall I make it, maybe 25. The width, I remember, was 20. So this is something I also many times do. I just draw my rectangle out here in the center, and then I can use something like the midpoint constraint to put it where it belongs. Huh. I hope this is useful. So now we kind of have that profile of that T-slot cutter. And now if I hit the Q for press pull, I can select these 2 sections here, and I can kind of make that cut that the T-slot cutter will do, right? So I'm going to go in about 80 millimeters cut right there. And if I hit OK, then you can kind of see what we got here. So we plunge this down with a T cutter, and now we are cutting along Y. But actually, of course, it's a round cutter, so the end here is not right. So let me just do that. So I'm going to open another sketch on that face, and I'm going to use that slice command again, because now I actually, when I remember about it, I actually like that, because now I can kind of see this here. I'm going to use the P for project again. I'm going to steal kind of like, when I go in here and select this, I can kind of select this profile here, like that, so I can get that line there. Because I don't know if I have to, I just really want this line right here. And then if we hit L for line, we can draw a line down to that endpoint there, because that, having just added that line, should actually let me go into a revolve and select that half, only half of it, revolve around that vertical line I just did, and that will make that half of the cutter there. If that went too fast, I apologize. Go back and watch. This will come out as a recording. Go back and watch that recording. If I go into the tools and into inspect and do a section analysis, maybe that would help, right? So if we just do that for a second, so the cutter's going to cut down and it's going to cut over to the end piece here. So this is kind of the profile of what we want the cutter to do. Let me just turn that off again. Okay. So far so good, Alex. So now we want to use that T cutter to plunge down and machine over. And my one original thought could be if I just went back into to a sketch tool and draw a sketch on the bottom here and hit alpha line and draw a line from the center point of the big hole to kind of the center point of the little hole. This is kind of what I want the tool to actually move down. So now, if we go into manufacture, to our cam, and I'm just going to make a setup, and this is why, if you wondered before why I drew everything in the centers, because now my origin is, I don't have to mess with that. You could think about going in and use something like the trace tool here. So the trace, let me just do that again, that was a little fast. On the 2D, go and click Trace. And now, if I go and select that tool, and I still have that from last week's video, so Alex's form mill, what has like this T-shaped cutter here. If I select that, and I go to our curve selection, and I select this edge, and hit OK, let's look at what we get. We are almost there. If I go in and simulate this, and I'm just going to turn it down a little bit in speed, it's going to plunge down, it's going to machine over, and this is everything I think Alex wants, except the last thing, what is that is actually rapiding out of the, see, this could be all good going up again. The going up is not good. Can you see that? It's machining down, it's all good. Going up is not good. And I'm assuming, Alex, that you have some cutting edge on this, or you're going to have to machine yet first. Now, if this is true, if this is what you really want, except the z-axis move up, then I'm assuming you're machining in wood, because I could not imagine that you could do this in steel. I just couldn't picture that, where the chips would go and all that stuff. I think that could be an issue. Now, and it's important to remember too, I think. And I know I say this in a lot of these, but the CAM inside of Fusion 360 is based on metal subtractive, standard CNC kind of milling. So I think that's important. So if you are working with wood or other materials, you're kind of aware of that, because you might have to think a little bit different in those materials. Now, if this was steel, the way I would do this was I would actually use a cutter that was smaller than what you're trying to machine. Because like I said before, there's a couple of things when it's steel. First of all, you need to get rid of the material. You would also need, normally you want to lead in and lead out, where the cutter actually comes on and off the cut. And just to show that, instead of making the tool, change the tool, because that was kind of like created already, I'm just going to do it with... I'm going to do it with making the hole a little bit bigger. But Alex, I'm going to come back. I'm going to show you how we could cheat and do this with the trace tool. But let me just show the other one first, and hopefully I'm not making things too confusing. So I'm going to just suppress the trace tool for a second. And let me just go back into our design, and let me just change a couple of these, because you would have to have either a cutter that is a little bit smaller, or of course something that is a little bit bigger than your cutter. So I'm just going to go in here, and I'm really just going to change a couple of these dimensions here, because Fusion actually knows where and where not there's material. So let me also just change the width of this. So that's making everything a little bit bigger. The way I would machine this normally would be probably just using a 2D contour toolpath. Still use the same cutter that we had before, but now I've made everything bigger. Then I will just select that bottom edge there, and let's just hit OK and see what we get. So when we do that, you will see that we get a warning on it, and whenever you're getting a warning on a toolpath, right click and hit the show log. And it will give you a contour was machined because the given lead parameters would cause collision. See, this is one of the cool things about Fusion and being inside of a solid modeling tool. It actually knows it will collide. So let me just go into the 2D contour, hit edit, go to the last tab, the linking tab, and let me just turn the leads in and leads out off. And let's try again. And now you will actually see we don't get a warning, and if I click here, you will see that we got some bytes, which tells us it's doing something. So let's simulate that. It plunges right down where we don't want it to. Okay. So let's go back in, right click, hit edit, go back to the linking tab. Now down here you can actually do an entry position. So let's select right there, hit OK, and let's see what we get now. So this would actually probably be a better toolpath. Now, you will normally have a lead in, lead out on your parts. And that lets you do cutter compensation in the controller of the machine. But you will actually find on most of your machines, you can actually go fairly small, at least my experience, you can go fairly small in your lead in, lead out. So the default here was 5 millimeters. If I change to a 0.5 millimeter, you will probably see it will actually let us do that. But what that will do, if I zoom in, is the green will give you like a little lead in and lead out. That is, at least if it's steel, is probably a little bit better way to do that. And again, Alex, I'm assuming certain things. I'm assuming that you have a cutting edge on the flute here, or you would have to remove this here with a previous operation, what you maybe already have considered. But this here would be a better tool path. I do get a red collision going up. But the fact that it has a lead in, lead out, and it's smaller than the exit opening, with the material maybe going somewhere, something like that. Okay, so I got that out of my system. Let's go back to the tracing operation again, though, because I do want to show you something that maybe is useful. If we go back in and we unsuppress that and just regenerate it again, still the same thing we have right now in that tool path, that if I simulate it, it's going to go down and go on, and then it's going up. And this is what I think you want to get rid of. You want to get rid of the up, per se. Well, you could actually do this in the code. If you had to do this every single day, maybe this is not the right way to do it, but if you're just making a few of these, we could right-click here and go into the post-processor. Now, with great power comes great responsibility, but I'm going to show you anyways. Let's change the name. I don't know why we have Nathan in here. Let's change that. So Alex's, I'm just going to post this code out here. And of course, this is a tiny little piece of code. But to do that trace tool path, this is what the machine needs. And when you get past the G54, turn coolant on, turn heights off, it plunges down in this line, and then it goes that Y 80 millimeters right here. That is actually when it's traveling across there. And then when it comes, whoops, let's see if I can move it down a little bit, like that. So this line here, line 18, Y80, that is when it's traveling to there. Then you will see the next one is Z up. Well, Z up means that it's just going to travel up 4 millimeters. What we could do, and then it's going to travel up another 15 on top of that. What we could do was we could go in here and click on this, hit enter, and enter our own line. And if we here wrote Y0, because that's where it started out from, was 00, that actually means that now it's going to go up, and then it's going to go back again. Now, you will not see it inside of Fusion. You will see this on your machine. And you might even consider, if we make a line between those two, the Y80 and the Y0, if you did something like G04, that's a dwell, and we did like P500, that will, depending again on your machine, that will give you a half a second. A G04 will give you a dwell of a half a second. So that will just let that cutter go Y80 down and just sit there for a half a second to make sure that it spins around a couple of times before it goes back again. So you could get around by doing it this way here. I hope this was somewhat useful for somebody. All right. I hope that was useful, Axel. Axel, I hope that was useful. Hope that was useful for somebody. Thumbs up if you like this. Thumbs down if you don't. And I love the comments. Again, this is just me trying to answer some of my emails here on what should be a Sunday, but it's actually a Monday. It's a holiday. It's all good. Next one here is from, who is this from? Let me see if the person signed it, if I'm missing it. This is from JC. JC, I thought we had JC last week. Maybe it's another JC. Hey Lars, I have a question about tracing. Not the tracing we just saw. In an imported decal image and would like to trace it. I lowered the opacity a lot so I can trace, but it has many curves and my lines are hard to get straight. Let me just show you what JC sent me here in an image. All right, So this here is, it looks like it's a car emblem as far as I know. I think it's actually, is it a Mazda logo? I think it's a Mazda kind of car. I'm not 100% sure. But what we're looking at here is a line going down, kind of trying to chase this. And of course, this, I think this was taken with a cell phone. But yes, that can be kind of hard to do. What you want to do, JC, is probably using splines instead. So let me just show you that, what I mean by that. So I tried to find this. I tried to find this online, but I couldn't. I couldn't find it where it was like looking straight at it. And you probably want something like it looks like you have that is straight at. So what I found instead was, well, let's look at the Mazda logo. Mazda logo. Mazda? I don't know. So I'm going to go in here and say attach a canvas, just like you probably already did, and select the face here. And I'm going to select this this logo right here. And of course, when you bring it in here, we talked a lot about logos, that you get an option to you can manipulate them in here. I'm a big fan of doing the opacity level here, leave that around 50 or so. And you could also, another thing that is good is if you get here and you move it around, is get that origin there kind of like situated somewhere can be kind of helpful. So what I wanted to show you, JC, is that instead of using lines and arc to do these kind of things, you're probably better off using the spline tool. So if I go in here and create a new sketch on this face here, the spline tool is a little bit better. Now, what many people will do with the spline tool is that they will click on the spline tool and then they will select somewhere around here and they will kind of like start clicking around multiple times. And it actually, you know, I think that was because that was how, I don't know, that's how we used to do it in the olden days maybe. So people trace it around like that. I actually am not a big fan of doing it like that. Control Z to undo. Let's go all the way back so we didn't have a spline tool. What I will do for this one here is probably just click once and then might click twice. Might try to click here and then one down here near the bottom. Probably right around there and hit OK. Because what you get is you get these handles and they are much better to control the spline width. And you can kind of adjust them. They will kind of, the more you get of these, the harder it almost gets. But this would be one way to kind of play around with the spline here in the end. And get a, now I didn't do a very good job placing the canvas on that origin, did I? Something. That's probably better right there. So I would adjust these spline handles as you're seeing here. Let's go back and edit it again. I would be playing around and try to match this up with our point here and get it as close as you want. When you got this all the way around, now these, I always talk about how you're going to turn your, if I just, yeah, let's just do one more. You always hear me talk about, so I would do one for there, and adjust that one to be somewhat close to, see, that's pretty good. I'm always talking about you have to fully define your splines or your sketch geometry. But for splines, I actually don't do that. What I do, let me just get the last, now I'm going OCD here, let me get the last one here. So you get that, JC? This is how I would trace around each of those. Yours is a little bit more complex than this. But then in the end, when I've done this, I would go and I would right click on each spline and I would fix it. Fixing the spline in the end is a much better way to do that on spline than trying to fully define them. I hope this was helpful. Oh, I'm not sure I got this one fixed, but whatever. I hope that's how I would do that, JC. That's how I would go ahead and work with that. Hope that was useful. Another option could be if you can get your logo. So your logo look like it's a pixelated image. You could use something like Adobe Illustrator or another program that can convert what is called from raster to vector. What means that you can break down a picture that is all pixels, you know that, right? Like all pixelated, into actually geometry that is lines. And then you could bring that SVG file into, you can bring that one into Fusion by clicking the insert and bring that SVG file in right there. That's another way to do it. If you don't want to sit there and trace it around. A couple of different ways to play with it. This is not necessarily Fusion 360's strength per se. Again, just like I talked about in the last section where we talked about CAM, that CAM is based on kind of metal and machining, machine shop type work. The CAD inside of Fusion is based on mechanical CAD, not so much on freehand stuff. But I hope that was useful anyway. Next one is from David Ott. Hey, David. Happy Sunday, everyone. Monday, it's Memorial Day, almost Sunday. This is just me trying to get through some of my emails. If you're new to the channel, you haven't subscribed, I would love if you would hit that subscribe button and hit the bell up there. It means the world to me. And the thumbs up and the thumbs down if you think this is stupid. Leave me the comments, whatever. It's all good. David Ott sent a great email here. He wants to do some 3D printing. He has a PDF of a model. And he was able to bring the PDF drawing into Fusion using the upload button, but can't really do anything else with it. Yes, so this is something I wanted to do for a long time. So thank you so much for sending this. You could click here and hit upload and select your file, and you could bring in, I have a PDF right here, you could bring in a PDF. The problem with that is that a PDF, well, most of you guys know this already, that PDFs are, well, they're not really pictures, right? They are more like, well, what are they? They're Adobe, some kind of a format thing. Many times we would get them, when I used to work at Ridline, we would get them as the 2D drawing per se, and then you're kind of like stuck with them, and how can you use them? You could actually use them as a reference to model up, but you would have to turn them into a picture. It's a little strange, but let me just show you anyways, because it's a good exercise. So I have a PDF here, and if I double click on this PDF, oops, let me just get out of Fusion here. Fusion was looking at it. Let me double click on this PDF. It should open up in as an Adobe Reader here, right? So here I have a PDF of a file. You can see that, okay? So what I could do was doing something like this snippet tool inside of Windows, and I could just kind of grab this 2D drawing like this, because a PDF, unless it's special, is not really better than a picture. So let's just hit save, and that's going to bring it into my, leave it as a JPEG capture, just so you see it here. So now inside of Fusion, what I could do was kind of using it as a canvas as we used before. So I'm going to go over here and click and say insert as a canvas and bring it in just like we did with the other ones. Now it's a picture. Now I'm going to do a couple of things in here with it though. I'm just going to place it in here for right now. Hit OK. Find a reference. Ooh, and this is not millimeters. This is inches. So I'm just going to switch my unit over. It shouldn't change anything for what we're doing here. Change it over to inches. What you can do when you're bringing this as a canvas, you can actually right click and you can calibrate that canvas. So if I go in here and I click right inside of this hole here and inside of this hole here, I can actually type in that 2.36 you see right there. That will blast it up much bigger. So now this drawing is potentially pretty dang close to my actually file. Now I will go and right click on again, and I will hit edit canvas, and I will actually turn my origin on. That's my origin. And I will move this one over to about close to one of these views. See, a print like this, if you're fairly new to kind of these mechanical prints, have different views. So this is the top view, there's a front view, and there's a side view on this ember bracket, whatever this thing is here. And actually I just noticed that I think we are missing a dimension on this for where this island is. Alright, that's for something else. So what we have now is we have this PDF brought in. It's sitting on the top view. It is to size, because we just used that calibration function. What I would now do was I would actually bring in another one. Insert, another attach canvas, select the front face here, select the same file, hit OK, and again I'm going to hit OK again. I'm just going to hit OK. And now that is sitting down there. Now this actually add a canvas. I actually need to flip the orientation, I think. It looks like the orientation on this one is wrong. If I click on this one, that will make it go that way. There you go. You can flip the view on these two here. You'll see what I mean in that in a second. Alright, so this is the second one. I'm going to hit OK to that. I'm going to do the same thing to that one. I'm going to turn the first one off. That's a little bit hard to see. I'm going to calibrate that one also. I'm going to use the exact same dimension I did on the first one. Click this here. Get as close as you can. Again, that is 2.36. That dimension right there. That's going to blow up. And then I'm actually going to do the same thing. I'm going to use the same corner, but on the view I want to use. So actually, instead of placing to the origin on this edge, I'm going to do it down to this edge. Because that's the view of the front we're on right now. I hope this makes sense. Hit OK. So if I now go back up to an isometric view and I turn the first one on, we kind of have the front view lined up. We have the top view lined up. We could also line up the last view, depending on if you need it or not. We're just going to do it for this exercise. So we're going to insert one more time. Last one. I promise, friends. Last one. This one again. Hit open. So that comes in. I'm going to turn the two first one off again because it's a little bit hard to see. Let's zoom in. I think that is the right one. And oops. Go back over and look at it. There it is. Let's right click, calibrate. Like that, 2.56. And this one here, it will actually be when I right click and hit edit canvas, I would actually bring it up to this view. Now, I will say one little tip probably, if I was going to do this in real life, I might actually just delete the other things out of here and only keep those three things we really need. So let me just rephrase, right? So if we go to the top view, we really only want this section here. The front view, we probably only really want this view here. And again, the side view, we only want this portion right here. But what this let us do, and I've done this a couple of times when I worked at Ritlam, and customers will send you prints, because this print you're looking at right here, if you are doing any kind of machining or anything, you know that these prints are gold, right? They're kind of what you have to use to align everything with. And if you miss something on the print, then it's normally on you. People normally be the ones yelling at you or laughing at you. So getting these prints right is important. Using this technique, it maybe take a little bit of work up front, but it have made me catch things in the past that I missed, versus just have like a paper version of it laying next to my computer and kind of referring back and forth to the 2 all the time and you're missing something. So this is actually I think a pretty good way to do this. So what we could do now with these free canvases is, and you maybe have figured it out, opening a new sketch, click on this one here, we can draw up a rectangle here. Now, I would still use the dimensions you see on the print. So 0.187 to do one, and the other one, the overall size of that one is on the bottom, down at the bottom view, but it's 2 inches and 87, like that. So now we kind of have that there. There is some holes, C for circle. So place a hole here, and the hole is 0.24, like that. And then you could D for dimension. So you see what I'm doing here? I'm just kind of using this PDF as a reference, as for me to kind of draw up this circle. C for circle. I'm going to draw another circle over here. Then I would actually do a equal between this circle and this circle, like that. And I would probably do a horizontal relationship between this and this there. And then D for dimension, and the one that we have been using a couple of times here, what is 2.36, right? So I'm using I'm modeling right on top of this. I know for some people this is going to seem a little silly, but this is actually, to me, have been extremely helpful way to do this. Now you can continue, and we could go down. We can look at the thickness of this is 0.08. So here's Q. Press here 0.08. So that gives us this view here. Now, if we turn that off and we go to the next view, see how we have the next one sitting right here? So now you could actually start, I could open up a sketch on this front view here, and let me start. We could do all the details because there's actually a detail view up here, but let me just make sure that I draw a rectangle here. And if I'm using the dimensions over on the side, actually, let me do it from the bottom up. It is 0.78, and D for dimension. D for dimension. And what are we looking at here? A width of it. The width here is that one right there. So that's 1.06. So you see how I'm using this as a reference. Now I'm assuming it's gonna, there's some dimensions here. So dimension from here to there would be 0.91, right? So now that is in place there. We could do something like the opening inside of it. C for circle. Draw that circle up there and do, so we know from the bottom and up there, that is 0.21, like that. And from this edge here to there is that one there, 1.16, right? So you see kind of how we're placing it. Now maybe we have to go over to the detail view to see it's 55. There's some things missing on this print though. 0.55, like that. And what's the overall width on this? I think that's missing. Oh no, that's this one here probably. From the bottom and up, goes over there. 0.59. That's not true. That's the top. Yeah. So we're missing. I don't know what this one's gonna be. We're missing. We're missing a height on this one, I think. We just leave it here. Now the last view, and I did this kind of on purpose to show you. See, if I turn it off, you see how this sketch is sitting here? But if I'm turning on the last one, the last view, you will actually see that it's offset. It starts over there. And that dimension is missing. But just in case you didn't know, if I hit Q and I hit that, you see how we can do that there. Did you know that in the standard extrude function, we can actually do a starting offset from? So if I do like, I don't know, 0.5, minus 0.5. See how you can actually offset that? So if you go in and look at there, maybe it's not 0.5, maybe it's 0.4, 5, 7, I don't know. You can play around with this, but if you didn't know that, you can offset that in, and I don't know what that thickness is of this one either. 0.278, close enough. Minus 0.278. All right. This is one way that you can start using PDFs inside of a file here to kind of draw things up. And of course, if you're missing dimensions, David, like I do here, you probably have to call the customer and make sure that you get that straightened out. But if you don't, if you have all the dimensions, this way here of using PDF files is something that I have used multiple times when I'm modeling things up. And even if you are, a little bit of a pro, this is a great way to catch those things. Actually, like I'm doing here, suddenly you realize, ooh, I'm missing this dimension. It's actually an easier way to see it, I believe. I hope that was useful. If not, thumbs down. If it is, up. And I love the comments. And if you haven't subscribed to the channel, I know that there are a lot of people who come across these videos who haven't subscribed. If you don't mind, I would appreciate that. You can send me scotch, but you don't have to. Just subscribe. That's enough. All right, enough of that. Thank you, David, for sending me this email. The next one here is from John from Minnesota. Hey, John from Minnesota. Thanks for all the super helpful videos. You're so very welcome, John. My pleasure. I have a question I can't seem to get answered. I sometimes create new features and then fillet them, but when I try to mirror those objects using the mirror by feature command, the fillets or chamfers gets ignored. Do you know why this is happening? And then the sun just blurred in through the window. I do not, but I might be able to help you. I don't know. If we go back in, let's start a new file here. So one thing about the mirror command, skey, let's do something that is 200 by 300, Q, press pull, 20 millimeters thick, so we have a plate. So there's a couple of different ways you can mirror, right? So if I go in here and say, I'm going to open a new sketch here, and I'm not going to fully define this. I'm going to extrude this up. Yep, that's fine. Let's add some fillets to it, just to make it a little exciting. Okay. If you go in and use the mirror command here, you get, first of all, you get different options in here. You can select faces. That's kind of like the default. If I select faces, I can go around, I can select all the different faces that I want to mirror. I think that might actually be pure, if that makes sense, for Fusion to calculate. But what I prefer to do is actually selecting features. It just seems to me to work, like it makes it easier for me that I don't forget to select something, because now I'm just going to select it down here. So I'm going to select this and these two features to mirror, a mirror plane, that could be this one here, and it will come over here. Now, this is maybe what to play with, John, is there is compute options in here. There's one called optimized, there's one called identical, and then called adjusted. You might want to try to play around with these, and it comes down to how Fusion is doing the calculation. Now, to my knowledge, other CAD systems that I've used would normally not give you 3 options in here. It normally just defaults to 1. So the optimized one is going to be the quickest calculation, and I don't understand all the ones and zeros behind this. The identical one is a little bit faster, and the adjusted one is the longest. And I normally select this one just because normally it's not a matter of time unless you have something very complicated. But what the adjusted one does, as far as I understand it, is that the optimized is the quickest, identical is a little bit slower, and then the adjusted is the slowest. And it's because the adjusted one will calculate every single phase and make sure that it solves. Because remember, with solid modeling like Fusion 360, it needs to solve everything in the end. And that's also what sometimes gives us some trouble. John, I hope that was useful. All right, let's move on here. It is Sunday. Sorry, it's Monday. It's Labor Day. I didn't get to do any live streams or answering my emails yesterday. I was outside. I got my deck stained. I got my front porch painted. I was super active yesterday. So now I'm using this Memorial holiday to answer some emails instead. Why not? Next one is from Chet Israel. Hope you like this. I have a question about Fusion 360. What is the best way to import an STL file into Fusion and then get it prepared for 3D manufacturing on a wood CNC router? Okay, so I'm going to pick out a couple of things of this one, Chat. I think this is really good if you're into CAM. I think this is... No, if you're into STL files, 3D printing, or CAM, I think you might like this. So what I'm going to pick out of this is the best way to import an STL file. I'm going to talk about how to get it prepared for 3D manufacturing for that. So let's jump in and take a look at this. So I'm going to open up a new file, and I have a STL file that I've been using in some different videos. The best way to bring in an STL file is to go to Insert and go and say Insert Mesh. And by the way, whenever you're working with 3D printers or STL files, the best thing is just to work with millimeters. I would say this, and I might get in trouble. Somebody can correct me. That's okay. My rule, Lars's rule, is if I got to 3D print something, I do it in millimeters. I don't try to go from imperial, from inches to metric. Just start in metric. So for this here, use millimeters and go and say Insert Mesh, and then bring in your STL file. STL file, yes. Now, when you're looking at this file, we use this one and other ones. It doesn't look super complex, but just know that this one is actually this is a pretty big model, as you will see. It's a big size of a model, as you can see. Now, if you bring it in like this, you get it in as a mesh file in here, and that might be okay for you. If I hit okay here, this might be fine for you. Actually, for what you're trying to do, chat, this is actually okay because you can machine mesh files inside of Fusion 360. This is just a mesh file. So let me show you that first. But if you are into 3D printing and working with mesh files, don't go away because you're going to like what I'm going to show you. But you can actually machine. So you said 3D machining. You can use all the 3D machine tools inside of Fusion. Actually works on mesh files. The trick is that when you select your setup in here, and you get of course you got to do all your work, like make sure you get your make sure you get your Z-axis the right direction and all this stuff. But the trick is you have to make sure that you select the model in the setup and select that mesh file. It needs that to know that it's machining the mesh. And then you actually also have to go in and you have to work a little bit with your stock in here. You can see the stock is a little bit off on this, so you have to change that too. But now what I'm trying to get at is that all your 3-axis toolpath will actually work with a mesh file. You just got to remember, like I just did, to click on that mesh file like there in the setup. You got to select that mesh file there. But you can see that it throws all these toolpath on it. You can completely machine it, 3D machining it. So I hope that was useful for you, chat. But I want to get back to it again, though, because it's not 100% fair for me to just stop there, I feel like. Let me go back in and open a new file, because I want to talk a little bit about mesh files. If you want to bring in a mesh file, an STL file, and it's big, like the one I have, there's actually a couple of tricks to it. One trick is to go in and turn the history line off. So right-click up here on the top, click Do Not Capture History Tree. That will get rid of the the line down here. Now click Insert, Insert Mesh, select that same file. Okay, hit OK. Now what you can actually do is you can right click on it and you can say mesh to B-wrap. And what that means is bringing an STL file to become a solid. Now, why would you do this? Many times we're doing it for the simple reason to, excuse me, and now the sun is going away again. The simple reason we will bring it a mesh file in to become a fully solid is so we can like cut holes through it or make it cut in half and do different things with it. It's not always necessary to do, but if you want to manipulate it, you probably want to get it to a solid. Now, when I do that here, though, I'm going to select it. You will see that the conversion has been aborted, and the reason is that when I brought this one in, look how many triangles there is there. 213,330 triangles. I said this was a pretty big mesh file. To me, that's a big mesh file. We need to bring it down, I think, around 15,000 or so. We can do that inside of Fusion, actually. If we go to click on your name, click on Preferences, go to the preview, and make sure you have the mesh workspace turned on here. You have that turned on. We can right click on it here, and actually, I think we have right click, and if we go, do we do convert? No. Right click. Oh, here they changed it. Up here, whew, getting old. Up here, there is a mesh toolbar up here because of the new interface. And if you click on the mesh tool, that will appear up there when you have a mesh body. When you have a mesh body in the screen, the mesh toolbar will appear, as you just looked up here. And in here, you can reduce the triangles. And you will see that I have kind of like the paintbrush selected here. So I'm going to change that to a window. Select the whole thing. And then now you can break down reduce the triangles. Now when you do this, it will get rougher. So let's just hit OK to this one time. So you will get less triangles, what means the model will physical change. It's kind of hard to see right now, but if we go back and we try what we did before, let's get back out to solids, right click on this and say mesh to B-wrap, hit new. You will now see it's down to 53,332. Conversion has been aborted, so it's still too many triangles here. And I've done a lot of live streams on this. If we go back in again, reduce it more. You can play. I would absolutely be playing with how the density is here to see what the trace limit is. I'm going to run it again. Let's go back into solid and do it one more last time. B-wrap. You will now see that it's under, I think it's 15 or 20. It's not under 13,332. And it says it's still large, but it can actually do it now. And it can turn it into a solid there. So chat, I hope that this was useful for you. So now you actually have that. Now it's a solid model. Now it has all those facets on it. You can change some of those with some of the mesh tool. That's another video. But I hope, chat, that this was useful for you, that you can actually apply free access toolpath. You said 3D machining on a mesh file. You don't have to convert it, but if you do want to convert it, that is the way you can convert that there. Now you could use all the CAM tools inside of that. Useful, chat? I surely hope so. It is a Memorial Day here in the United States. It's a holiday. It's almost like a Sunday. Just getting through some of my emails here. Next one here is from Mark. And Mark said, "Hi Lars, I watched Rob Lockwood's video about master modeling a year ago." And then he left a link. I definitely have to show you this video. So let's go out here to YouTube and let's actually instead type in this guy. Rob Lockwood Fusion 360. And it actually comes up right here. But you don't have many videos out there. Rob Lockwood is how do I describe Rob Lockwood? Let me click it. This video here. You should definitely go and check out this video by Rob, Master Modeling in Fusion 360. So I have known Rob now for, I would say, 4 years, 5 years maybe. Rob is a fantastic guy. Rob is one of these guys that when you give him a piece of software, he will stretch it and find out exactly how far it can go. He's super smart. I don't get a leg to the ground compared to Rob. He's way smarter than I am. But he has created this video. So I can't say enough good things about Rob. This video here is talking about master modeling, and it's definitely worth watching. To Mark's question in regards to how this will change in regards to the new what's it called again? Oh man, I'm losing my mind. Derived function inside of Fusion. How do I think that will change? Well, it's probably Rob to answer this question better than it is for me. Let me just talk a little bit about what it is Rob is talking about when he's talking about master modeling. So primarily what Rob does, and I have done this in my videos too, I'm maybe skipping one step of what Rob is doing. The idea is that you open a brand new file, you create a layout sketch, that's what I normally call it, but you create a layout sketch. So let me just draw a couple of sketches here. And let's go in here and add a slot. I'm not quite sure where I'm going with this. Maybe I do need Rob to help with this. But the idea is that you create a sketch that kind of that is fully defined, that has the main thing of whatever it is you're going to model up. Now, in what Rob does in his master modeling video, you should definitely check this out. He saves this then as its own kind of file. So he goes up and will click save, and then and I'm going to do that well, I can do that. Hit save, and let's make sure we put it in. I have an Ask Lars Live folder. Let's call this one Rob Lockwood. He is a super guy. He will save this file, then he will open a new file, and he will now insert that first file that he had into in his video, if I see it right. So you'll go in, and it's probably got to update because I just brought, there it is. So you will now go here and say, right click and say insert into current design. We're going to save this file first. Insert this into this next file. So now you actually have the original file called Lockwood, and then we have this new file. And then from here, what you could do is you could start doing different things. So if we go back to the original file in here, and let me just, I figured that this is not, the way this was not super good. So we're going to save this. I'm going to make a change. It's going to save this. That means that one will come along to this file, right? You see how I kind of like link these two files? So now if I went in here and I do a revolve around these things here and do this. So now in my second file, I now have kind of modeled this up. And if I go back in my original file here, my original Rob Lockwood file, and I ever change anything in here, then it will update. And what it does is it just assures that it kind of just assures that everything is kind of, if you have multiple people working on a file, that you're not messing up things when people are working on files later down in Watch Rob's video and you will get further down. What Mark is asking is, okay, so I have this file here. Can I just use that new going derived from that? And I would imagine that derived is in here somewhere. I don't even know where derived is sitting from in here. I thought it was in here. All right. ASCII derive. Okay, it's right there. So you can find it this way. Going derived, yes. I think that Rob would probably tell you that now you could achieve the same thing by using the derived function to send this into a new design. So kind of doing the same thing through both of them. I hope this makes sense. It was a long answer to your question, Mark. I do think that Rob Lockwood will use the derived function. I would love for Rob to answer that. But yes, again, go and check out his master modeling video here. It's super good. Rob is a great guy, and I think it's really useful to think about this. What I have normally done when you've looked at my videos and using this layout is I would normally not separate the sketch from my revolve. I would just have left the sketch up in the top one up here. I actually have a video. If you go to my channel, I actually would have a video here. Go to my channel and you go to playlists and you go to the lives when I did all the different live streams, and click up here so you get the whole list. Hang on. And the way that I'm finding things in here is actually Control F. Search, and if I type layout, I'm wondering if it will not appear. Maybe I didn't call it layout. I think actually I called it skeleton. Maybe. Let's see. Sometimes I also gotta just look for the for the thumbnail to find something. It's not perfect. I know. There's no skeleton in here. What the heck did we call? Yeah. Skeletons in the wood cabinet. If you find live stream number 112, you will see the way I normally do, kind of what Rob does. Master, you can call it master layout, you can call it skeletons, or you can call it layout sketches. But definitely watch Rob's video. Rob is awesome, and I'm definitely not going to say that my way is better than his. And the sun keeps on changing, so if I'm suddenly shining a lot on my face, that's why. All right, I'm going to move on here because now it was supposed to be a short live stream, and now it's getting long. Okay, next one here is from Simon. Simon is Norwegian, and he asked me, by the way, your name do sound Danish. Could that be right? Yes. I am originally from Denmark, but I've lived over here in the United States for about, I think 2 months from now, it's going to be 20 years I've lived over here. I think your videos are really great. Thank you so much, Simon. And again, this is just me trying to add a little bit more value to your Fusion 360 experience. Thumbs up if you like it. Thumbs down if you don't. And if you haven't subscribed to the channel, it would mean the world to me if you hit the subscribe button and the little bell next to it. That way, you will make sure you get these videos. I am designing he's into cabinet making, and he's doing he was using some 5-axis, and he's trying to do a fillet. And I actually have I think I have a pretty good image. He sent me an image. I love when I get the images. And I think this one was interesting. We had to do this one. Because if you see here in red, I think this is a pretty normal for a lot of us to try to add like a transition between here. And there's a lot of different ways you can do this. Now, in most other CAD systems that I've used, this could actually be very tricky and almost to the point of what we call like master modeling. We were just talking about master layouts using Rob Lockwood's techniques, where we want to use surfaces and things like that. But I want to show you two different ways, and hopefully that is useful for you, Simon. So open up a new file here, get rid of the tree. So let me just model something up that is close to what was just provided here. So let's do this. New sketch, side. Let's do a rectangle that goes up like this, 100 by 100, like that. Maybe we do, that was like an arc on it. So let's do an arc like this here. Q, I'm not fully defining anything. You should do that. And then we're gonna go ahead here and open another sketch on here. And what I'm gonna do is I'm actually gonna do a spline, because that's what it looks, just to make it a little trickier. I didn't do a spline. I'm gonna do a spline, I said, and then I selected the line. Amateur. Oops. Okay. Because it looks like that there's a little bit of bow to whatever it is that we're trying to do here. And let's just draw a line over here and close this off in good fashion. Hit Q and draw that out there. Okay. So what we're looking at, this is my draw up of this. Maybe it should be a little bit closer. If you hear a lot of rumbling in the back, I got the 3D printer going. Okay, this is maybe a little bit better. Let's look at Simon's picture again. Kind of like a transition there in red. There's a couple of different things I want you to be aware of. First of all, the standard fillet command actually have some pretty cool functions in here. If we go to a variable radius, you can actually start playing around with variable radiuses. What could be extremely helpful in here, where you could go in and select this line here, make that a variable. We could also select another edge, and now I'm being like a little. So you can start playing around with some of these. Now you might also risk that they don't completely does what you want, but this will be my first instances. You can start playing around with these, and you can actually control the curvature on the tangency in here. You can actually also do setbacks down here, so that's a whole other kind of type. If you do a setback one, and I'm probably not a specialist in all this stuff, so let's go in and select this. So you can actually go and start playing with a lot of the different ones in here. Alright, now I'm messing around and I'm not doing it right. Isn't this typical? Fillets, setback, variable radiuses. So we got this one here, so that's a variable. No, I thought setback needed a point. Yeah, there we go. Right? We need some points on this thing. There you go. So you can see here that you can, with setback edges, so let me just do that again. Let's delete these out again. Undo. So I'd probably be better off select the fillets, select the setback, select this variable radius here. For the setback, I'm actually going to select a point here. And then now, before I do the setback, this is what happens when Lars don't. There you go. And now if we make that, I'm not sure which one I'm playing with. If one of them is the fillet, I'm just about ready to abandon this. I have to do another video on setbacks, I think. Somebody right now is yelling at me. Alright, we just did it before. Okay, I'm getting an error on this. Play around with the setbacks. I gotta work on that. The other thing I wanted to show you, sorry, is actually something that I think is more interesting, and that's using the sculpt environment to try to do what you're trying to do here, Simon. If you go into the sculpt environment, we've been in here before, and we go in and we select a flat face, and I'm just going to select on here, and I'm just going to draw kind of like a blanket, like this. And as you probably remember with these blankets is we can completely manipulate them by right-clicking and hit Edit Form. And what we could do was we could start playing with kind of how we want that edge to be on this edge here. So let's just select this, and I'm going to hold on Alt and just get another segment here and start dragging this one out there. So what we can do in here is we can play around with this part here. Let's move this up a little bit. And we can start making the shape that you maybe want this to be. So I'm just making this in all different kind of weird shapes. And if I exit out of it, this actually becomes this is actually kind of a surface. And what you could now do was, you will see if we go into bodies, this is now a surface body. Now you could do a split body and select our core body, select our face here, hit OK to cut with that, don't have extension on, cut with that, and now this body, and then now we actually get that shape of that blanket we just did with the surface. And if you wanted to play more with it, we could go in, we could right click, we can edit that feature. We'll right back in where we were before. Maybe we take this and we make it more bow shape to it. Like that. Hit OK, get out of it. So now it's a bigger piece right here. We hide that. Now you can see how you can sculpt that. I would actually be pretty big fan of using this technique to achieve that cutout right there versus getting in and using other stuff. I hope this was useful. The filler thing, I got to practice a little bit more, my setback fillers, but that is also an option in there. All right, I think we're just going to run through the next one a little quick here. After an update today, I couldn't post my program. I posted yesterday. Seems to be a machine. This is from Chad Kurtz. So an issue with posting code out for CAM. It's also not recognizing mesh body stack. So it looks like there's something going with an update that is not right. What I would recommend anytime you have an issue, the best way to simply do it is to do Fusion 360 support forum. Search that on Google, Fusion 360 support forum, and you will get out here and you can get into the forum and post in there. When you post into the Fusion 360 support forum, there's all kinds of people in there. It's a great place to get support. Autodesk people are in there. This is absolutely the best way. So I hope that was good for you, chat. All right, let me just run through the next one. Next one here is from Jesper Gerster. It looks like it's Danish because we're writing in Danish. I would like to know, how can you make text in Fusion 360? So if you want to 3D print text, that was actually one of the absolutely first live streams I did, if not the first one. It was one of the first ones. Live stream number 05. Pick a letter and beginner to advanced. So if you go and open up Jesper, go to YouTube and search Last Live '05. You should get this. This got to be in my old office even. Yep, old office. Got the guitars in the background. Go and look at that one. That should help you there. Hope that was useful, Jesper. Dennis wrote, can you do a video about epoxy river tables? Epoxy. You know what? I don't know much about these epoxy tables in here. This looks super cool. I don't even know. It could be a fun thing to do. You know what? Who does it a lot? Who maybe to reach out to? That is Evan and Caitlin. I spelled your name wrong, Evan. Evan and Caitlin. Sorry, Evan. Go to Evan and Caitlin. They're right there. They have done. They do a lot of epoxy stuff. They are super. Close me out there. They are super awesome. Evan and Caitlin, great people. Go and check out their ones for some epoxy. You know, I wouldn't mind trying it. It could be fun. I also want to do some. I have some different ideas. I gotta hook up with. I gotta buy Jimmy DeResta a steak dinner or something like that, and bring him a 6-pack. Because I also want to do some foundry stuff. I think it will be absolutely cool to 3D print. The 3D printer is going to the Ultimaker is running over there. I think it would be super cool to 3D print and do some casting, aluminum casting. Next one here is from Yasin Ergo. And Yasin have been very persistent, so I wanted to make sure I just touched on him. He is trying to do like a canopy for tutorial for like a parametric way for doing like a quadcopter. I know you're not going to be enough satisfied with my result. Sorry. He sent me this image here of what he's trying to do and want to do it parametrically. What I would do, and I think that the best tip I can give you for this is literally to go into Fusion and try to do it parametrically in the sense that I would probably do a center rectangle. And I don't know what size your quadcopter is. Let's do it 300 by 500. Draw something up like this, right? That is parametric, and I would use that. I would actually use that Rob Lockwood master modeling, we just talked about earlier, and then I would go in and do the insert canvas, and I would bring in that canvas there for this, but I would do it so everything kind of matches up. So again, what did I make it, 500 I think? So again, if I go in here to the canvas, right click and calibrate, we try to be as close to these holes as possible and do that. I think I made it 500. Did I make it 500? So I would try to draw up. So that's pretty good right there. The rectangle would also have to be down to there. But I would try to use just the layout here as a reference. And you could probably get up by draw the center up here very detailed. And then maybe do these legs and mirror them over. So maybe even do half of it. But I would use that master modeling I talked about before with that Rob is using to make sure you have some really good defined sketches, and it's going to take a little while to just start modeling them up that way. If you watch some of the other videos the ones that I've just been going through, Yasin, you would see kind of, I think, the idea behind it. Last one here is from John Curlsiles. Sorry if I'm mispronouncing your name, John. I generally have a shortcut for parameter on the toolbar, but since switching to the new toolbar, running into an issue with getting that one up. I'm not sure what's going on, John. You might actually want to go also to the support forum, because you should absolutely be able to go to the Modify tab, find the change parameters, click on the three dots, and say Pin to Toolbar, and it should show up on the toolbar, and you should have it there. And when you don't want it anymore, you can just drag it right off. But you should be able to go to Modify, change parameters, click on the three dots, add it to the shortcut, and that should bring it up there. If you don't see that, John, then I would recommend that you go do a Fusion 360 support on Google, get into this forum, and post it there. All right, how are we doing with the lighting? Lighting's probably pretty good here. Not overexposing myself. I just heard the 3D printer stop. That means that I am going to stop on this Monday. What should actually be Sunday, but I got busy. It's Memorial Day weekend. I hope you're doing well. I hope this is useful. I'll do what I normally do. I will chop these up into a couple of different videos that comes out during the week. So if you didn't feel like sitting through the whole live stream, you absolutely didn't have to. Looks like we're still good on the Facebook and hopefully also on the YouTube. I really appreciate you watching these. If you haven't already subscribed to the channel, it would mean the world to me if you did so. This is just me trying to add a little bit more value to your day. As my role has changed at Autodesk, I do not have the same amount of time to create videos. So I'm doing this on my off days. Thank you so much. Thumbs up if you like this. Thumbs down if you don't. That is okay. And as always, I love your comments and things like that. So, until the next time, I hope you have an awesome, awesome day. Take care, folks. Did it stop? I don't think it stopped. Take care, folks. I don't think I have this one set up for the shortcuts. Hang on. Is it going to work now? I don't know if it's going to work now. It won't work. Why wouldn't it work? All right, I'm just gonna end this one on that bothers me when they don't work. Doesn't it bother you when things like this don't work? Maybe it's because I have the wrong one set up. Now I think it's gonna work. I had to try it. I'll try it, or if I'm just gonna shut it off.